Good afternoon, everybody. Welcome to the 26th edition of the InfoVisFHP talk series. In this series, we want to stimulate a discussion about the potential of visualization by bringing together practitioners and researchers from the growing field of data visualization. The talk series is organized by members of the Urban Complexity Lab at the University of Applied Science in Potsdam. If you want, you can find the previous talks online. A link to our archive is in the description below. I'm Tobias Kauer, and I'm an associated researcher at the UC Lab, and I'm a PhD candidate at the University of Edinburgh in Scotland. It's the third time that we are having this talk series as a virtual event, which I know is a pity because we all want to go back to normal. But on the other hand, it's also a nice opportunity to invite speakers and viewers from around the world. Our guest today is Dr. Benjamin Bach, also from the University of Edinburgh. Benjamin received his PhD at the Aviz Group at Inria in Paris and worked as a postdoc at Harvard University and also as a visiting researcher at Microsoft-Research. He now is a lecturer in Design Informatics and Visualization at the University of Edinburgh. His research designs and investigates interactive information visualization interfaces. And with that, Ben wants to help people explore and communicate and also understand data across media, such as screen, mixed reality, paper, and also physicalizations. Today, Ben will talk about visualization empowerment and how we can make visualization tools and design knowledge and also learning material accessible to ever-growing audiences of data visualization. Before we go into the talk, let me do some housekeeping. Ben will talk for about 45 minutes and then we will have a quick Q&A session. So I encourage you to post your questions to the YouTube chat and we'll then go through them in the Q&A session. And with that, I will stop talking and pass the mic to Ben. Welcome, Ben.
Hello, everyone. Thanks, Tobias, for the introduction. Thanks for the Potsdam team for inviting me. You will see my screen shortly. Tobias, can you confirm that you see the slides?
I see the slides, yeah.
Perfect, great. So thanks again. It's an honor to be here. And I think this talk was actually planned to be physically in Potsdam probably 2 years ago, but you know, here we are. So thanks again for inviting me. Today, I want to talk about a topic that for me personally is getting more and more interesting. And I want to spread this interest of this topic. So in a way, I want to talk maybe more about questions, and I want to raise probably more questions in this talk that I can give answers just because this topic is so new and of course underrepresented. And as researchers, we are always more interested in the things that we don't know and then talking about all these projects that we have done so much so long ago. So come with me and try to think about this question: how to empower people to use visualizations. Now you may think, well, this is kind of, I mean, is this a really important new question? And you may think, well, look, we have had lots of discussion around tilted, three-dimensional, exploded pie charts. And we all know that, you know, there are certain things that you can do and certain things you cannot do. We have heard a lot about truncating bar charts, and there's a lot of work around this. Alberto Cairo, just to mention one. So, you know, there are these kind of deceptive visualizations, and in visualization classes, we always discuss these examples. And it's always quite an interesting activity. If you show people these visualizations, these deceptive visualizations, and ask them, you know, can you find the errors? Can you find all the errors? So again, these kind of deceptive visualizations, there has been research around. There have been evaluations to evaluate the level of deceptiveness, of how much these visualizations are providing a wrong impression, a wrong picture of the data, so to say. So just again, a study from Pandey et al., who are measuring these the impact of these deceptive graphics. So in this sense, there has been a lot of research, empirical studies that come up with these guidelines to say when do visualizations work and when do these visualizations are deceptive. And of course, every practitioner or everyone who's really working with visualizations, either as designers or as users, and I'm sure in the audience, there are people on both sides, there are always exceptions. And you never really, you never can apply the guidelines that come from research, for example, about deception, to your specific visualization problem that you're having just one-to-one. There are always exceptions, and you always need to know the rules in order to break them. So in this case, we already know, let's say, a lot about what does it take to make people understand and not misinterpret visualizations from the studies, from everything that has been written. And again, I'm pointing to the work of Cairo and Pandey et al. But I want to look a little bit further, because there is this concept of visualization literacy that also, I'm sure I'm not telling you anything new here, which has been defined as sort of the ability to read, to write, and to create visualizations. So there has been work around this concept, and I think it's a very, very important concept, but also a concept that, even though it has been, there is some work that tries to define it, some work that measures. I want to kind of, in this talk, test a little bit of how wide this concept can actually be of visualization literacy. So for example, and again, I want to go beyond these examples of simple deceptive, of truncated axes and tilted three-dimensional pie charts. So for example, if I show you this network, if I show you this visualization of a social network that captures about 100 years of social interactions between medieval merchants, and these medieval merchants, they travel across Europe, and then later on they travel to Africa and the Americas. So they're moving in space, but also these relationships, they evolve over time. You have sometimes like clusters coming up of people who help each other mutually, and then you have someone who is creating a new business relationship in another country, and so on and so on and so on. So what I want to tell you, what I want to say here is that this is not a network. This is a representation of a network, because all that I'm telling you, like time, space, different types, all these stories around people, you know, this is not shown. This is just one specific representation of the network, but it is not the network itself. It's not the data. In order to represent networks, we have been working on many different networks, many people, including me, to create visual representations for networks. And if I show you those visualizations and I tell you those are all dynamic networks that change over time, it could be social networks, it could be brain networks, could be travel, migration, anything networks. You may say like, well, it doesn't look like a network, but in fact, it is just different representations. These are different representations. And you can have specific representations like these ones without wanting to go into detail. This is a representation that is really well to compare two different networks. Think about your social network. How was it before COVID, and how was it after the or during the lockdown? Which relation did you maintain? Which relations became stronger or weaker, and so on and so on. This representation is really good for this. Or if you think about this visualization, it's really good to show how a network changes over many, many, many years, not just 2 years, for example, but from your early childhood to now. What are the friends that you maintain? What are the groups of people that you join or leave, and so on and so on. And again, there are other representations like this one, which is really good to communicate, to say, look, this is what's happening in my network. And I don't want to show you all this complexity, all these kind of weird and novel visualizations. I just want to focus on the very simple message of something in my network is happening, and that has a huge impact. So all these representations are good for something, and it will take time to learn them, because you need to understand, if I want to compare a network, if I want to compare to understand my relationships before COVID and during the lockdown, I should go for this representation. It has been tested in the lab with other people or with experts, these visualizations. So there is science, there's evidence behind them that they are superior than, for example, representations like this. And and so on. So this is kind of, it's a complexity. It makes visualization usage more specific. It is not just, hey, is this deceptive or not? It is, can I read this visualization? Do I know what these things mean? Do I know when to use this visualization? Do I know when to use this one? Do I know how to interact with these visualizations? Because visualizations today, a lot of them are interactive because we can interrogate our data and so on. So I'm speaking of kind of using an empowerment in that sense as understanding visualizations as a craft of creating visualizations, of designing visualization, of understanding the science behind visualization, and saying there are researchers that empirically evaluate visualization techniques that show that something works and something doesn't work under specific conditions. And also to know to navigate these science and understand the guidelines and the limitations of what researchers in visualization say. It is about understanding visualization as a workflow, where you say, I'm picking those visualizations that I need for my purposes. It is about visualization as a method to say, if I look at this network, then here's what I want to report in my research findings. And I back up these research findings through a visualization. So instead of saying, this network has so and so many nodes, and there's so and so many nodes with a high degree centrality, and there's so and so many clusters, I like, look at this picture. A lot of information is in this picture. And if we show these nodes moving on a map or in time, we can infer a lot of insights about these data without having to rely on the classical statistics. So visualization as a method in discovery, but also in communication. This visualization empowerment is also about tasks, because as I've just said, if I want to compare two networks, then that is my task. And I can find a visualization that is working best for this task. It is about strategies in saying, well, if I solve this task and this task, then here's how can I solve this with my visualization, my interactive visualization. I show you some example later, but I just want to sketch this kind of space of where I think this is why visualization, using visualizations or working and applying visualizations is not as easy as we all thought. If at any point we thought this, but of course we all engage with things that we think, oh, they're kind of easy, and we know them, and then we try to sort out the problems. So what are the strategies that you can use to explore, for example, these social networks? Where do you need to click? What interactions do you need? What tools do you need? What workflows, again, data cleaning do you need? What is the network in the first place? If I can talk about this later. So this is what I mean by strategies. It is also about communication. So I show you this network, and I can tell you what I see in this network, and you need to believe me, but I need to convince you, and I need to show you what the colors mean, and I need to tell you what the nodes mean, and so on and so on. And if this is a very complicated visualization, then I need to explain you this visualization first, and then I need to convince you that my findings are really true, that you can follow me through the visualization. And it is about exploration, not exploration, but exploration. I'm sure Tobias can just what's the name? Live change my screen. It is about exploration and knowing that this is not a network. This is a representation of a network, and I need to ask the visualization. I need to ask my interface, my computer, to tell me more about this visualization, to show how things change over time, to see where things are in space, and so on and so on. And without actually having a specific goal and say, look, oh, it's kind of beautiful. What can I learn about this network? I don't know so much about this network, but just tell me what is there. What are the stories in that? So I could go on here, and this is certainly not complete. And that's why I'm giving this talk, because I want to see what resonates with you guys, and what do you think, what is your experience about where do you think visualization is really a challenging field. So I'm coming from Edinburgh at this point, where we're building the FH Group, the Visual Interactive Data Group, which has a growing set of people from different backgrounds, from social sciences, from design, from product design, from arts, from biology, from data science, and so on and so on. And we engage a lot in, so to say, case studies. That means projects with external collaborators. So this is a project, for example, that Tobias was working on early in his PhD on visualizing piece processes. So I want to show you some of these case studies and why they are, and kind of reuse some of these concepts that I've just thrown in. So this is kind of a very unusual visualization, I would say. It's probably nothing that you have seen yet, and you may want to ask, like, what is this showing? So in analyzing piece processes, which was is an ongoing collaboration with piece researchers from the School of Law, we want to understand how are these piece processes coming across. So they have a huge document collection, and I spare you the details, but what this visualization is showing is over time on the x-axis, it shows each piece process, which is one of these lines in a country such as Afghanistan or Colombia, whatever, how it is moving from a very unstable ceasefire on the top to a very strong and solid implementation on the bottom. So an ideal piece process would go from the very top left. Over time, it would move to the implementation period. That's the ideal. And that's what kind of, I guess, our collaborators thought that is what we can see, that kind of most piece processes are kind of more or less following this or something. But what we see instead is when we just plot each piece process in every country in the world as one of these lines, then we see this is quite an unstable, these are unstable processes. And you can use your mouse and hover over and just explore. You don't need to know so much about the background to understand actually what all this is showing, but you can just explore and see, oh, this is an interesting line. This is an interesting line. What is it telling me about the piece process behind it? Now, this is kind of a simple example for exploration, but let me come back to this example of networks, where we have many different representations for networks. And we're building a platform that allows people to jump between these individual platforms, where they can upload their data, see them in, oh, okay, this video is not available anymore. That's amazing. Where we provide some of these visualizations in the same platform. This tool is available under Vistorian. You can Google this, you will find it, which is for network for exploring dynamic, multivariate, and geographic networks, such as geographic networks. And we want to provide all those millions of visualizations that are potentially out there to people to say, like, we want to go beyond individual node link diagrams. We want to provide these more unusual visualizations, but are really, really powerful. And I don't have the time today to go into these. I just want to mention this project as an example where many visualizations come together as kind of multiple views, and you can jump between these views and look at your network from different angles. Unfortunately, in the video, it would have, no, it's working, but I will move on in the interest of time. So we've done this work on social networks and geographic networks. If you're interested in more visualizations for geographic networks, have a look at this wonderful work by Sarah Shetler, who just published a survey on geographic network visualization, geonetworks.github.io. And we hope that over time we can include more of these network visualizations into the Vistorian over time. There are other concepts in visualizations that make visualization complex, but also powerful, if you will. I don't know if you have heard of space-time cubes. Those are these conceptualization where you have a space as a 2D plane, and then as things are changing in this space, for example, people moving, then you move this space up and you end up with a three-dimensional space that represents your data. So in this case, we're having a few people here on the right side who are joining for a meeting and then they're leaving again. So this is a concept from geography, but you could explain, you could take this concept and apply this to many other domains. You could, for example, this is again the example with the people moving in space, and it has been used a lot to tracking commuting patterns of people who are living in the suburbs, and how did they change over the day. You can apply this to networks as well to see how is my network changing over time, which links are appearing, which links are changing in weight, and so on and so on. You could use the same for trajectories of, in this case, I guess it's cars moving, and the kind of red and green in this example is just showing how strong the traffic is. And then again, over time, you could see which times of the day at which places in space are most congested or most fluent. The same concept of this space-time cube has also been used to explore videos, where the space is just a single frame, and then you move through the whole video, you end up with this three-dimensional space-time cube. It's maybe more an arts project, but if you think about surveillance videos, you can imagine a surveillance video as such a cube. And if you filter out all the pixels that are not changing between the frames, you're going to see where in your videos are people crossing a door or something like that. So it could help to quickly spot specific things in your data. And there are many, many more application cases, energy usage over time, and so on and so on. So the interesting thing is that these visualizations, these rather complex visualizations, give you a mental model and a metaphor to understand your data. So it's not, I'm not saying that these are for trajectories, for networks, for whatever, for videos. I'm not saying this is the best visualization you can ever create to support people in their tasks. All I'm saying is that this is a rather, well, I don't want to say intuitive, but a rather simple metaphor of how your data is. There's only space and time, and that is fairly enough for you to understand what patterns I have. So if some things are staying stable, like in this case, it means that people are just not moving, or that something is not moving, whether you can understand from the wiggliness and the craziness of these lines of how much movement there is. And this in turn then helps you understanding, maybe exploring your data, so to say, and maybe coming up with hypotheses and saying, look, I should do this, maybe I need to interact. And interaction is quite an important concept in this space-time cube work. We have a paper on this, which I want to point you to for more information, but these 3D volumes are really becoming a space to explore and a metaphor for exploration. And in this paper, we argue for taking this three-dimensional space and the interactivity to 2 dimensions and saying, okay, how can we keep this metaphor in 2 dimensions, but at least getting people into the mood of, I need to explore my data. I need to select specific slices in time. I need to push data away. I need to filter. I need to explore, look at it from different angles, rotate, and so on, and so on, and so on. So all I'm saying is that this model hopefully helps people understanding that there is a need to explore because the data is inside. Now, inspired by this 3-dimensionality, we have then worked on trying to take, look, can we take this into mixed reality with stereoscopic display? So it always looks crappy when you show these examples on the screen, but because they are recorded on a stereoscopic camera, and you can guess from this video here that this is a 3-dimensional hologram that sits on your desk in this case. So you can freely rotate around. This was the HoloLens 3 years ago, the first HoloLens version, technically not very sophisticated compared to what we have today. But the idea is that we have these data cubes in front of us, and using this small cardboard here, again, state-of-the-art 2017, you can explore this cube. You can create cutting planes. You can cut into the data. You can remove points. You can select points, and so on and so on and so on. So you could put your data into these space-time cubes and then explore them in 3-dimensional holographic vision. I'm seeing that this is loading, so I hope my connection is not breaking up. And again, with colleagues, we then thought, well, this is actually a super interesting concept, and it feels really immersed to look at this data. So we're working on tangible controllers to help people better selecting points, because it's quite challenging if you do this all the way. It's like we are used to mouse and keyboard, and these technology has been evolved over decades. So people are super precise with their mouse. We tested this in the lab, and those people who were actually gaming using video games a lot, they were super fast in solving tasks that we asked them with the computer, because we were comparing the computer to the mixed reality display. And this kind of tangible, if you imagine you need to move your hand like this all the day, or at least for a few minutes, this is super tiring. So we worked on some of these tangible devices, and it's really interesting how precise they are. You can include force feedback and so on to drive this exploration. So again, all of this is about exploration, about interaction and selection, changing parameters of your visualization, and so on and so on. So those are most of the projects that I was talking about are sort of case studies. They involve some sort of experts, and it always, well, what we try to show always is how these techniques, how these novel techniques succeed, where they're successful. So there is definitely need, and people appreciate these visualizations. They are interesting, and people want and need more of them. And we're also teaching a course at the university to professionals, which is quite an interesting experience, because we want to know more about the people that we are working with as visualization designers, as visualization researchers. So this course is a really nice opportunity for a researcher to try to see what people in working positions, not students, I'm not talking even about postgraduate students, I'm just talking about professionals who work for private businesses, for government organizations, for NGOs, who are freelance, who want to change their career. Some of them want to become visualization designers. They just start getting their hands dirty with D3. Others are working for the government and they're creating infographics for the latest government data. Others are working for company and they need to create dashboards for their bosses, and so on and so on. So there's a super rich set of people that we're engaging with. And what I want to say is that from these case studies and from this course, there is such a wealth of problems that really kind of motivates this talk and thinking about this project of, this empowering is so much more than just deceptive graphics and just telling someone what visualizations exist. Because there is visualization on the one side, and it can show patterns to humans, and that's what the visualization does. It just, everything it shows is just pixels in a specific color and a specific layout, nothing more really. And the humans then interpret these patterns and then make their conclusions. But there are also these questions that people have asked about the visualization, that they have to ask, that they have to, this is why they need interaction. They need to click, they need to change, they need to filter, and so on and so on. And this is an active process. So visualization is not this passive, well, I see it and it's great and I get it. And I hope I have convinced you if I ever had to convince you. But I just want to reflect on this, on the challenges that are there in making this an active process. And again, I'm speaking from my experience in running this course, teaching professionals, running case studies with professionals in law, researchers in law, health professionals, and so on and so on, and many projects that I couldn't just all list here. And it's always the same questions that we're getting, and it is a complicated project. So when you explain visualizations, when you think about visualization, there are these sets of tensions that make the use and application of visualization so hard, and that this kind of empowerment so hard. We have theory on one side, which is saying about color theory, perception, visualization representations. We have guidelines, we have empirical studies. And then on the other side, we have the tools that kind of don't really support that theory, or that do something completely against the theory. So there's this famous discussion ongoing. It's like when you create a visualization tool, think of Tableau, for example, or Jeffy or RAWgraphs and so on, without blaming any of them. How can you make sure that you prevent people from making mistakes and making bad graphics? How can you prevent people from creating deceptive graphics using these tools? So can this even happen, right? If we give people a hammer, then they can do with this hammer whatever they want. They can smash in windows, but we can't really prevent people from smashing in windows by the design of the hammer. We have other tensions in visualizations, and this is when you explain someone, or someone comes to you and says, I want this data to be visualized, then you start explaining, well, does it have to be static? Can we do this in a static way? Do we need interaction? To what degree do we need interaction? And from a case study perspective, this is also really interesting because people need to know why you're making specific decisions. There are tensions between designing and coding. Of course, this is more maybe from a skill in the background perspective, quite interesting. How much do you need to code? What do you need to design? What's a good prototype? Which coding language should you use anyway? What's the purpose of this project? And so on and so on. Planning and iterations and more of these tensions where, yes, every project needs planning, but in visualization, it's you have a prototype, you see it's not working, you need to come up with a new idea. And this is also an interesting process of explaining to your collaborators, your clients, or whoever you are designing for, or whoever you're teaching, that there is this tension between planning and iteration, which, yeah. Again, the tension between general knowledge and individual cases, guidelines and exceptions, science, empirical things, findings, and then experience, personal experience, personal opinions, creativity. How creative can I be in a visualization design? How conservative do I need to be? What are the state of the art, the basics that just make something work? Authority is someone telling me how I should do things versus I have an opinion, I have my own experience again, and so on. So again, this all just to make it more complicated and to hopefully motivate why we need to think more about visualization empowerment and what are all the challenges and the frameworks that we can apply to teach people, to educate people, to guide people through this big cloud universe of visualization, if you want. So ideally, we had clear guidelines. We just have a handbook that solves everything. Ideally, we had a clear terminology. Often people ask like, oh, but in the other book, they call this chart so and so. And I think, yeah, that's the way it is. But isn't that the point of science for you guys to figure out this terminology and saying, yes, that if we were really scientists in the in a sense, and observing nature, but we're researchers, we're engineers, we're designers, and this is just a human. We're just looking into what humans create, really. We're not observing nature so much. Ideally, we had standard tools that can do all the stuff and that you can learn once, but the universe of tools is just exploding these days. Ideally we had simple workflows, but every project is using their own workflow. Sometimes you need a coding language. Then again, you find that, oh, this has already been done. I was wasting my time if I just had known this earlier, and so on and so on. Ideally, we also had agreed success criteria for this is a good visualization. This is a visualization that works. From a scientific perspective, it would be brilliant because we can just evaluate what works and make proper suggestion. But again, it depends on so many things. Ideally, we had standard resources, again, books, websites, trusted resources. Ideally, we had activities that we can make people going through in order to learn about sketching, about data collection, about choosing a representation, about learning to code, and so on and so on. So activities that you can run in the classroom, but that you can also run on the web and saying, if I want to learn about sketching, here's an activity, some small workflow, some sheets that I can go through with my group, maybe because you're working in a company and then you're tasked to do something and there's just a methodology or an activity that helps you doing this, and so on and so on and so on. So, but we don't have this. So we need to work on this empowering and give people tools and think how we structure our knowledge as a scientific design and engineering community and everyone who's engaging in this and how we work on this. So let me briefly in the last bits of this talk go through some examples of what we're trying, or what are kind of some projects that we're doing in Edinburgh to help empower people. Even if, again, this empowering is a really big concept, and this is a very conceptual talk as well. So if I show you this example of these two charts, then most of you have seen both of them, I'm sure. But how many of you can tell me the difference between the notion of this one and this one? Because they're meaning different things in those two charts. Here they designate a confidence interval, which tells me how sure I am that the mean value I'm calculating here is really between those two. And in this visualization, it means something completely different. It is about the interquartiles. So it tells me that almost all, that in this case, 50% of my data is between here, and this is the median, this is not the mean, and this is almost all my data points, my sample points are between these two ranges. So I don't want to go into detail again here, but it's just, this is a specific visual language that has been created that is part of, I guess, the standard visualization repertoire. However, why I'm giving you this example is I'm saying, how can we support people in reading visualizations and understanding these differences without going through the textbooks, without having classes in visualization and just shortcutting this way. So you can go to books, and there's also the beautiful dataviscatalog.com that shows you what an individual visualization is, and you get examples and so on and so on. There are books by Alberto Cairo and Andy Kirk who list specific visualization techniques where you can learn about these things. Now, what we thought is, well, it would be nice to have sort of a cheat sheet. So when you do an analysis, when you read a visualization, you want to just have a single PDF or something that you can throw up and say, oh, look, here's how I read this visualization. Here is how this visualization works. So for example, in this project, we were looking into illustrating the construction of visualization. So you can really quickly recall how I get from, in this case, a scatter plot to a parallel coordinate plot, how they are related. And these are small illustrations that you can, that I, at least I'm using them in my teaching to explain people what is a parallel coordinates plot. Then, as I said, cheat sheet. So you want quickly answers. What visual patterns do I see in my visualization? What patterns can I see in a PCP, and how do I interpret these patterns? If you're not familiar with the PCP, the parallel coordinates plot, go to the visualization cheat sheet website, and you can learn a little bit about this. Also pitfalls, everything that I need while reading. So these things are, the idea of this project is that we have these cheat sheets that we can put on our desk, and when we look at or do a specific analysis, we can just look, okay, this is what I'm seeing, this is what I'm seeing. Here I need to be careful how to read these axes. I know that sometimes the axes are inverted, sometimes they can be truncated, and so on and so on and so on. So we created many of these cheat sheets. You can see them all on the web for 6 different visualizations. And I'm super curious to see if this is something that, as a designer as well as a user, speaking to both of these groups, do you think this is helpful? Where do you think this is helpful? What cheat sheets would you create for your own visualizations? If you're coming up with novel visualizations, publish cheat sheets with your visualizations, and teach your users how to use them. Because at least in the scientific community, whenever we present a new visualization technique, all the knowledge is buried in this scientific paper that is super hard. It's not accessible to people not familiar with this community and this science. So again, curious to see what cheat sheets you come up. Please send them to us. We're more than happy to host them one way or the other on the website. And this can be cheat sheets about other sorts of visualizations that you're using daily, that maybe you have created your own cheat sheets already because you had issues using an adjacency matrix or a parallel coordinates plot or many of these tons of visualizations that exist. So reading visualization representations is one thing. Interactive exploration is another one. I was talking about this for ages and in the earlier part of this talk. How can we explain people to go through and say, I need a strategy. I need to first look at the visualization like so. Then I need to look over space. I need to see where are my nodes. Then I want to look over time. When are these relationships happening, and so on and so on. So currently we're running this platform, the Vistorian.net, which provides you with these visualizations, and we're anonymously looking into how people proceed through these visualizations. How do they use them? Do they interact at all? Which visualizations they spend most of the time, and so on and so on. And we want to get in touch with people. So if you're interested in network analysis, if you're doing something like this, either go to the platform or get in touch with us. We're really interested in seeing how can we support you in learning strategies, in learning these visualizations, and learning to deal with your data, your workflow, and how can we eventually improve the tool for you. So in looking at the logs, we want to find where common issues of people, and again, it's all anonymous, and your data will also remain on your computer. We don't have any server in the background. It's entirely anonymous. So we don't have a lot of progress on this research. It's just ongoing research, but we're currently looking in this data. And the third part that I want to talk about is communication. How do we communicate and present with visualization? I was already giving this example of here's my network, and I want to convince you what I've seen in the network. So this is kind of the classic example where people are using visualizations in a report or in a scientific paper. And you always have these chunks of text and the visualization, which is kind of separate. And I'm super confused because I need to find when the text points to a graphic, a visualization, then I look at the visualization. I forgot what the text said because I'm understanding the visualization. Then I go back in the text. I need to see where have I been, where did I stop? And then I need to read on. And then I have this constant switching back and forth. So this might not be optimal. So we did come up with an idea we call data comics. We wanted to learn from the world of comic and the visual language of comics. What we do have is in comics, and I'm not talking about action hero comics at this point, is a panel. And this notion of a panel is super interesting because it says, here is an important thing I want to tell you. It has a bit of text, usually pictures. It's combining text and picture content to explain, to make a very specific point. And then this panel is followed by other panels, and it's preceded by other panels. And in our brain, we then can understand and read the story. Okay. So this is why comics are really, really powerful for explaining complicated issues. At least this is one of our motivation was that. So we looked into, comics have already been used a lot to explain scientific concepts. I can only point to the comics by Matteo Farinella, who's a brain scientist and now making comics about science and nature, apart from brains, but also to explain all sorts of things. We're kind of just used to these sequential art, as it is also often called. And we engaged with students, with professional designers, with ourselves, with colleagues, and we created lots of comics because we wanted to explore this huge space of data comics and see how can we explain insights of data in data with visualizations through comics. So these comics can have very different forms. You can be very, let's say, puritanistic, if you want, just very clean. You just show the events, as in this case, which is showing the changes of alliances in in Europe before the First World War. If you're familiar with this period in time, you know that there was a lot of diplomacy and alliance going on. So this comic is just explaining these steps and trying to make clear how these alliances evolved and what happened in the just before the First World War. We have other comics that are playing a lot with style and metaphors, with characters. This one is done by a professional designer, Terry Poe, who's now working for a company in London to explain healthcare and healthcare concepts, also using comics. So there's not a lot of classic data visualization in this example, but it is in a way a very interesting example because it's not overwhelming people with lots of visualization, which to some people I have heard are scary. Data is a concept that is scary to some people. We have other examples that play even more with styles. These are examples from students in illustration who come with a real specific training in illustration, in art, in narration, and so on and so on. And they had no idea about data visualization or data science or anything. And you see what kind of visualizations and explanations and stories around the data they came up with. Because in this workshop that we ran, we said, look, any data that you're interested in, if it's your own data or you find it on the web, and over 2 weeks, we were then guiding them through creating a comic. This is just examples. Eventually, these comics had a few pages. It was just beautiful to see them all on the wall. It was an amazing, amazing experience. So again, you can play with everything. You can play with the style, with the narration. You don't need any text sometimes. This is famous examples from Isotype on a guns in 1920s, where there's no text, but it is a visualization. It explains, it shows data. So to facilitate this process, I said we run workshops. We ran a couple also online. We created comic patterns sort of to facilitate the storyboarding, because comics, you may say, well, I'm not an artist, I can't even sketch, and this is all very scary, and this will just look crappy. But really what this is, what this all is about is coming up with the storyboard and thinking about the narration, thinking about how does my speaking, my text, my explanation supports my visual and vice versa. What is a good visualization that helps me getting my point across? So it's a really nice activity to learn about storytelling, learn about linearizing your thoughts as a data communicator and so on. These design patterns are online, also on the websites of datacomics.github.io. I think I forgot to include this in the slides, but datacomics.github.io is kind of our website where we collect a lot of data comics. And again, if you come across data comics that are not listed on the website, if you create your own, and sometimes you can just do them on a napkin. I forgot to include the slide of Sejong Wang, who was creating a comic on just a napkin, but it's online. Yeah, and just to convince you, if I have to convince you even more, we printed these comics on big boards for conferences. This again with a social science collaborator, and you can see how you can present research to audiences using comics, for example, or at least inspiration of the comic languages. Okay, in the interest of time, I will cut short a little bit here. We also worked on a project to explain statistical analyses. You can find more on this on statscomics.github.io. And again, we're curious to, well, work with you towards your own statistic comics, explaining your research for posters, for blogs, for social media, make your research accessible, transparent, and accessible to lay audience or even your peers, because whatever lay people understand, your peers will just love. That's a bold statement. So again, I point you to the paper and to the website if you want to learn more about this project, but I need to speed up a little bit. We also have just recently accepted a scripting language that helps you adding interactivity to comics. We have worked a lot on static comics, but we have now an approach that you can script interactivity, like I can hover over a panel, I can click on a panel, I can show more panels, I can do nonlinear storytelling, I can import sliders and play with the data and so on and so on. And this is meant to be kind of a trade-off between the very static comics, apologies for the video, a trade-off between the very static comics, the curated author, and allowing for exploration, allowing for personalization, allowing to go into specific details. So again, the language is available on the web, and again, we're around to help you if the documentation is not enough. And lastly, this is some work we did with Tobias, who is hosting the talk today on participation, of how can we understand how people are actually what are they understanding from the visualization? After this communication, even if you create a comic or whatever, your visualization is out in the world, but often you have no sort of feedback about, do they understand it? Do they read it? What is going through their head? Are they liking it? Are they having questions? Are they exploring the visualization? Are they engaging in some way? So with Tobias, we did went through, I forgot the number, it was a big number of Reddit threads on visualizations. We're looking at what are people actually saying when they talk about the visualization. So we came up with these, we called them reactions, types of reactions. So people, to classify all those comments. And so we found people making observations, some are making conclusions, hypotheses, clarifications, and so on and so on and so on. Some are sharing their personal information and saying, look, oh, this is interesting data. When I was, it was about bushfires, and he was basically explaining how it felt to be close to these bushfires and kind of amending the data with personal information, testimonies, and so on and so on. So there is a rich set of how people actually react to your visualization. And part of this project where Tobias is now looking into how can we capture these data and understand these data, what people are doing. So let me finish to go back to this initial question: how can we empower people? I was working through a lot of information about exploration and process and demonstrating examples of how we work with experts and what are the issues that come up when we teach to professionals. So let me try to finish with an agenda where I think we need to think more about these issues to help empowering people. So first of all, what skills? I have in this talk just listed a set where I think interaction is a skill, creating strategies is a skill, defining tasks is a skill, certainly designing is a skill, knowing what tools exist is a skill, learning tools, what are strategies to learn tools to not, and so on and so on and so on. So what are the skills that we really want to teach in visualization courses to different audience, to professionals, to students, to designers, to people with a background in data science, and so on and so on. We need education tools. Beyond cheat sheets are static, but at the same time, we want websites where people can learn more about adjacency matrices if they need to use them for the analysis. How can we go about beyond simple static cheat sheets? We need advice. We need to work on advice. We have been building this forum, VisGuides, which is an open forum for everyone to ask visualization questions and post their projects and getting advice. So how do we encourage people to express themselves and express them well and saying, this is my problem, this is what I tried already? And how do we get people to answer to this one? We can also, how do we use this in teaching, and so on and so on. As I already said, we need to think about activities of, this is the famous example from the 5 design sheets methodology from Jonathan Roberts, to help people coming up with ideas for sketching and ideas for visualization design. So what other activities can we do? We need to think about platforms. In this case, we started building a platform to collect tools and feedback on tools, to help people find tools, but also to rate tools and to tell us what they think about tools, what are the problems. And of course, we need to understand what people are actually doing, whether this is for participation, like in Tobias' work, or how they are using interactive tools. How can we support their workflows, from data collection, data storage, to participation, collaboration, updating data, and so on, because visualizations are touching on many, many different workflows. And there are interesting things about prototyping. So can we very quickly allow people to come up with ideas and test them with real world data? So this is an example of this interactive comics scripting language, because it's just really meant for prototyping for people who have no idea of JavaScript and don't want to learn JavaScript. Reflection as visualization practitioners, designers, researchers. How do we reflect about our own practices, and so on? So if you're more interested in this topic of visualization empowerments, we're running a workshop, Viz activities at IEEE Viz in October. The deadline is 24th of August if you still want to submit a paper, but you're also welcome to submit activities if you have run any activities in your group, in your class, in your company, whatever you're doing, or submit challenges. And these are really just small blurbs of a few hundred words, because we're interested in a variety of opinions. So you don't need to submit a big workshop paper. And at this point, I want to kind of close with this one question for everyone. What are the challenges that you see that relate to what I said? What are the challenges that you observe in teaching, engaging people with visualizations? And what do you think? Yeah, just interested in seeing your opinions. And that's our group again. For our website, you can see much more. So I think that's for me. Thank you so much.
Wow, Ben. Thank you. That was a great talk. That was so much information, and I think people will really appreciate the abundancy of links to platforms, to research papers, to, I think, really practical things that you can just use in your visualization practice every day. So that's really great. While I wait for questions to trickle in, as a reminder, you can just post your question to the YouTube chat, and I will then collect them and ask Ben. While we are waiting for questions to trickle in, I have one myself. I really liked the what you said about visualization literacy and the idea of a visualization repertoire that becomes some kind of a major consensus of what we can show people and expect them to understand it. And obviously this major consensus is changing over time, because people are learning new visualizations. They are just exposed to new visualization ideas. How do you think, because there is a hen and egg problem inherent to this, how do new things come, how do they migrate into this consensus? How, for example, do data comics or novel network visualization techniques migrate into this consensus? And what can we do to maybe push that a bit?
I think that's the question I'm having. I mean, I think consensus is always coming from people agreeing, and this is a temporal process. So we can always, I mean, as designers, researchers, I think we can, creators, let's say, we can explore new forms, and we need, if we're convinced about these new forms, a new visualization technique or a new approach like data comics or something, we need to push for it. We need to show people the potential. We need to say, look, this is what it serves. So for example, printing all those comics and putting this in the conference is kind of pushing for it. And it is an investment, and it takes investment for everyone. So and eventually you hope that these things are coming up. But I think what I'm also saying is that we need to think about how, after we've created these artifacts, a comic, a visualization, and so on, to facilitate, to train people in taking it up. If we create a new visualization for networks that shows specific relationships over time, we need to, it's not just the documentation. And at the moment we're going through and trying to train people in these new network visualizations. But what is actually interesting is it's not so much about the visualization itself. It's often the process that leads to the visualization. So how can I format my data? What is my network actually, right? I have this ton of data, and before even specifying what are nodes and links in a social network, that's quite easy, because usually people are nodes and the relationships are links. But think of a network that includes affiliation. Then you have two types of nodes and everything becomes more complicated. So those are some of the things where that makes the training, I think, hard. Even if you have a new nice visualization and everyone wants to use it, it's these kind of pragmatic things that make it hard, I think, if this is answering the question.
It is, and it's an interesting challenge, and it's interesting to hear how you think about it. We actually do have a question from the chat. Thanks, Ben. Do you have an opinion about automated or AI-aided decision-making or guidance in the creation or exploration process of visualizations in regards to how they empower people?
I think it is quite useful. It can be quite useful. Not being an expert in AI, I think there are very many application cases. What I think is crucial, that you always have a human in the loop. So to say, the computer can propose you, for example, 3, 4, 5 different visualizations, but then it's up to the user to say, oh, look, this is actually what I want, and this is what serves my task. So I think you can use AI probably in life for whatever you want. This is my general opinion. As soon as you have a human in the loop and you train people of how they can interact with the model or with whatever AI you're using, and say, okay, if you do this, the model can learn, and people need this understanding. It would be nice to see if you have a specific scenario or system or whatever in mind. So I'm happy to follow up on this.
Yeah, that's interesting. Another question from the chat is how to reach people who are my target group. How can you reach people who are my target group? I must say, I do not understand the question really. Maybe Alex, you can rephrase it and post again. While you do that, I will ask another question from the chat. Do you think it will empower people in the reading and creation of visualizations, or in the long run, take power from them? I think this is an addendum to the AI question, also by Marianne. Will it empower people or take things away from them, take power away from them?
You're talking about AI in this case?
Yes.
Well, I think again, it's like sort of driving a car. You can drive it properly. You can die. I'm not saying AI kills you, but we have seen examples where this happens really. So I think it's all down to the people. It's this old question of how we use technology and what are we going to do with the wonderful technology we come up. I think these systems are only as intelligent as the people who create them. That's one of the rules of software engineering. And I think the same applies to AI wherever you apply it. These might be strong opinions, but from a visualization point of view, I think we are very much working towards making these models transparent, making them understandable to people, making them controllable. So working on this interface, and there are many people in the community who do this. So I really think you need this human always. And Ben Schneiderman, I think, has some nice talks on this as well. I haven't had time to catch up with this, but have a look at Ben Schneiderman's talk, who's talking about human in the loop and an AI system. So yeah.
Yeah. Also, what comes to mind are the VisX AI workshops at the IEEE Vis conference, which are super helpful to explore this. I mean, it's a data-heavy process, and why not use visualization to empower that? Now, I do have some context on the how to reach the target audience question. Does Ben have some tips on where you publish the Viz to reach the people you would like to benefit from the Viz? Because it's, just posting it online and hope for the right people to come might just not be enough. How do you reach the people who are your target group?
I don't know. What we have tried in the past is we went to conferences. We targeted specific people in these communities. The Historian project, for example, was born by a collaboration from historians who said, oh man, you have all these visualizations. Can you just create a single node link diagram that you can move through time? That was done in an afternoon. And then soon the next thing comes. And then we said, let's go to these conferences, let's have workshops. And then they invited us back. So we gave full day workshops on this tool, on everything. And a full day is not enough, I tell you. So I think from an academic point of view, that's, it's always good to have liaisons to all these communities. If you're completely unattached from any community, then trying to find people who advocate your ideas in this specific community. I think it is so important because there needs to be someone that this community trusts. And by community, think of, children or government organizations or academic groups, someone who's advocating, who them trust, whom they trust, and who speaks their language, and who can also explain these visualizations to them. Often, there's so much terminology about visualizations and even AI, and just people use these terms without knowing what they mean. So I think That might be an option if you're really looking for close contact and your visualization being used, because there's so much training. And again, communities have different methods as well. If we go to the social science workshops and communities, they have different methodologies from us computer scientists. So they use different words and they want to know, how can I use visualization? And this is, I think, again, this empowering, because you need to understand them, you need to talk to them, you need to train them, you need to invite them to you, these back and forth. It's not, we think probably through internet and social media, we just put it out there and it will somehow survive, but I think it doesn't.
So if I understand correctly, the idea there would be to basically get rid of this dichotomy between the audience that you communicate your visualization to and the content creators who create, but get into dialogue, engage in transdisciplinary work.
Proactively, I think. I mean, if you look at the internet, again, this is a general opinion, there's just so much information, like whom should you listen to, right? Whom should you trust? Which threads should you follow? If you have someone who, who's explaining you things and making you aware of that some of this is interesting, then it's good. And again, for visualization, some people, they understand it right away. They say, oh, this is exactly what I need. And others you need to convince. And then of course it's up to you to decide, well, I'm investing the time to convince them because really I need to convince them to use visualizations or this visualization because, it's showing how bad our planet is at the moment. This is really, you need to push for it. In other cases, people believe it right away.
Yeah, cool. That's super interesting. We have 2 more questions. Thank you so much, Ben, for this presentation. I very much sympathize with the tensions you shared and agree with much you said about the craft and science of visualization. I wondered why it should be ideal to have clear guidelines, consistent terminology, all these things you listed on this one slide. If we do have these teaching methods, bespoke tools, unique genres, and supportive community, why should you put effort into standardizing things?
So, interesting question. I think there is two levels to this standardization, or on the one side, you could say we try to cram everything in the boxes and we try to make it fit, and then we have authority to make people use it. And the other thing is it's just impossible. And I think it's just not possible for visualization, and it should not be possible. What I'm saying is, ideally, if you're observing nature, we can find laws of nature, gravity, for example. To some extent, we can all agree that this is happening. And for visualization, I think we want to have such an agreement that some things work or some things don't work. I'm not saying that there should be these guidelines. If they were there, it would facilitate our work, because we could check, for example, if a visualization is, in teaching, for example, you could say, okay, I grade this visualization according to the guidelines. It's something, if this were possible. But again, I don't think it is possible in visualization. And it's kind of the beauty that, there are these laws, you can observe them in the lab, but you have opinions, you want to be creative, you want to break those rules. We're not science, Naturwissenschaft. We're not that, right? So there's room. I hope this is answering the question. It was a long answer.
What I get from it is you are best at breaking the rules you know well.
Yes, there's always, you want to structure any process, right? You want to have a methodology to follow, but then you can diverge from it. And I think visualization is not even there, that we have so much clear structures.
Cool. We have one last question. I'm curious whether you've had experience in introducing data visualization to fields and departments in universities that are very textual, text heavy, such as history. What do those conversations look like if you have introduced it to those fields and departments?
So I'm assuming you're talking about the researchers, not the department admins.
Yes, I think so.
So usually everything starts with some sort of, what do you want to know? And what is your data, of course, because if you have text data, then you need to get the step of somehow abstracting these text data. However you do this, whether through NLP or through manual human coding, is up to you, but you need to abstract, you need to ask the questions and saying, from this, let's say, text corpus, I want to know this and this and this and this. And this is one of the things that we had when we worked with the peace researchers, because they had these document collections and then they had kind of coded them, but there's so many codes. So we need to decide on what is an interesting question. And then we came up with these peace processes showing how are they, are they stable? Are they unstable? Are they converging? Are they diverging? And so on and so on. And then, it's a hand and egg problem. You can say, look, this is our task. Now let's find a visualization to it. Or you show them visualization. And I think this is actually how it was in this case. We said, look, if you could think about this like this, and then they finally understood what we meant, what the potential of visualization. I remember when we sketched this on the whiteboard the first time. And then they can say how information from their data relates to it. So what I want to say is there is a huge gap, and people need to understand that they need to abstract, they need to come up with these questions to then specify visualization. You cannot just put a text corpus in a black box and then you get the answer.
Very cool.
And I also think,
No, go ahead.
I think I should stop here, because this is a conversation can last long, and I know we're way over time, so I don't want to stretch you too much.
Okay, then I think with that, I want to thank you again for your time, for your slides, for your input, for your inspiration, for all these resources that you shared. That we also people are also in the chat mentioned they appreciate the abundance of links. So yeah, thank you, Ben. Thank you to all the people who tuned in. If you are interested in more of these kind of talks, you can visit the website, our archive in the description below. And yes, I think that's it. Thank you, everybody.
Thanks so much again. Happy to follow up offline, and have a nice weekend.
Bye-bye.